day everyone, welcome to our YouTube channel. Today we are going to focus on the topic arc sectors and circles. Now for a circle, we have different parts of a circle. Now the distance from the circle is called the circumference. Now a part of it is called the sector. When it is suspended by two radii, it is called the sector. So this is the sector. So now the distance from the middle of the circle is the diameter. So the D here is the diameter, and half of the diameter is the radius. So we also have the segment and we also have the chord. Alright, so let's go to our examples. So for the first one, we have an arc subtends an angle of 105 degrees at the center of a circle of radius 6 centimeters. Find the length of the arc if pi is 22/7. So for the arc is AB. The arc here being from AB is equals to, we have 105/360 times 2 pi times 6 centimeters. You might be wondering, how do we have this formula? So you want to calculate for the length of an arc. The length of an arc, the formula is theta, the angle, over 360 degrees times 2 pi r. The r is the radius. That's how we got to this point. Alright, so in this case now, I will have 105/360 times 2 times 22/7, which is pi, times 6 centimeters. After calculating everything, this will give us 11 centimeters. Alright, for question number 2, we have calculate the perimeter of a sector of a circle of radius 7 centimeters, the angle of the sector being 108 degrees, if pi is 22/7. Now we have an arc here. Alright, this is AB. So for the arc AB, we are still going to use the same formula. We had theta over 360 times 2 pi r. So this will give us 108, the angle being given, over 360 times 2 times 22/7 times the radius in this case is 7 centimeters. Alright, so if you calculate this will give us 13.2 centimeters. Alright, for the perimeter of the sector AOB, that is AOB. To calculate the perimeter of that sector, this will give us this plus OB plus the arc, which is AB. The arc there is arc AB. Alright, so we have that OA is 7 centimeters, OB 7 centimeters, and the length of the arc we got 13.2 centimeters. If you add 7 plus 7 is 14 centimeters plus 13.2 centimeters. So if you add 14 centimeters plus 13.2 centimeters, that will give us 27.2 centimeters. Alright, the next question we have, what angle does an arc 6.6 centimeters in length subtend at the center of a circle of radius 14 centimeters? Use pi as 22/7. Now we have the arc here, xy is the arc, which is 6.6 centimeters. So now to calculate the arc, now we have the arc xy in this case is theta over 360 times 2 pi r. In this case, r has been given as 14 centimeters. So now, in this case, we have been given the arc to be 6.6. So 6.6 is equal to theta over 360 times 2 times 22 over 7 times 14. So in this case now, I will have 6.6 equals to 7 goes into itself, 1 goes into 14, that's 2 times. So I have theta over 360 times 2 times 22 times 4, 22 times 2 will give me 44. So in this case now, I will cross multiply. So I will have 6.6 times 360 is equals to 2 times 44 is 88. 88 times theta is 88 theta. So now I'm going to divide both sides by 88 to find theta. So I'll divide both sides by 88. This cancels this. So theta is equals to 6.6 times 360 divided by 88 will give me 27 degrees. So the arcs obtain an angle of 27 degrees. That means that the angle here is 27 degrees. Now the next question we have, an arc subtends an angle of 72 degrees at the circumference of a circle of radius 5 centimeters. Calculate the length of the arc in terms of theta. In terms of theta, okay. So now this diagram represents this. So now we have that if the arc subtends, if the arc subtends 72 degrees at the circumference, then it also subtends 144 degrees at the center. Alright, how is this possible? We also have a law that the angle at the center is equal to 2 times the angle at the circumference. This means that the 72 degrees we have here will give us 2 times 72 degrees. That will give us a sum of a product of 144 degrees. Alright, so getting that, we have that because the question says we should calculate the length of the arc. To calculate for the length of the arc, we have x, which is equals to 144 degrees over 360 degrees times 2 pi times 5 centimeters, which is the radius given. So now if we reduce this, we have 16 over 40 times 10 pi. Alright, so 0 cancels 0, 4 goes into 16, that's 4. So we are going to have 4 times pi. So our final answer is 4 pi centimeters. The reason why we have our answer this way is because the question asks us to calculate the length of the arc in terms of pi. Alright, for example 5, a sector of 80 degrees is removed from a circle of radius 12 centimeters. What area of the circle is left? Now to calculate the area of a sector, the first place, area of a sector is theta over 360 times pi r squared. Now in this case now, from the question now, a sector of 80 degrees is removed. That means this is 80 degrees. This has been removed from a circle of radius. The radius in this case is 12 centimeters. So what area of the circle is left? Now from the angle of sector left, that will be 360 degrees, because the angle of the circle is 360 degrees. So 80 has been taken off, so 80 degrees. So 360 minus 80 will give us 280 degrees. So to calculate the area of sector left, that will give me 280 degrees over 360 times pi r squared from the formula we have. So now in this case, now we have that r is 12 centimeters. So this will be 280 over 360 times pi is 22 over 7 times 22 over 7 times the radius in this case is 12. So 12 square. So now if you reduce this, so we have 7 over 9 times 22 over 7 times 12 times 12. So if you simplify this, 7 goes into itself, 1 goes in here, 1. So if you simplify this, this will give us 352 centimeters squared. Now for our final example, we have calculated the area of the shaded segment of the circle shown below if theta is equals to 22 over 7. Now we have to use subtraction to calculate the area of the segment. Now it means that area of segment is equal to the area of the sector. The sector here is x o y, the sector. So x o y, that's the sector, minus the area of, this is a triangle there, so the triangle is triangle x o y. Now the area of the sector minus the area of the triangle. So now this will give us, so area of the sector, we have 63, the angle that is being formed, over 360 degrees times pi times 10 raised to the power of 2, the radius raised to the power of 2, minus the area of the triangle. Now in this case, now since the triangle does not have the height, so we are going to use a different formula. We have 1 over 2 times 10 times 10 times sine of the angle. Sine of the angle is 63 degrees. So now in this case, now if you reduce this to its lowest term, we have 7 over 40 times 22 over 7 times 10 squared is 100 minus 1 over 2 times 10 times 10 is 100 sine 63, that will give us 0.8910. Alright, so all these are in centimeters square. Alright, so in this case now, if you reduce this to its lowest term, it will give us 0 cancels 0, so 7 times 22 times 10, okay, 7 goes into itself, 1 goes here, 1. So I'll have 22, 34 goes here, goes into itself, 2 times goes in here, 11. So I'll have 11 times 10 divided by 2 minus 2 goes in here, 1 goes in here, 50. So I'll have 50 times 0.8910 centimeters square. So if you break this down, this will give us, goes here 1, goes here 5. So 11 times 5 will give us 55 minus 50 times 0.8910 will give me 44 10.55 centimeters square. So now if you subtract 44.55 from 55, this will give me 10.45 centimeters square. We've come to the end of our exciting lesson today on arcs, sectors and circles. I hope you learned a lot. Please kindly subscribe to our YouTube channel for more exciting mathematics videos. Thank you.